test of relationship. So there is a word called test of relationship, and there are different kinds of relationship. So I'm writing down different types, and you can check yourself whether you are aware about it or not. The first and the basic kind of relationship is known as association. The second kind of relationship is rank correlation. And the third type of relationship is Pearson correlation. The fourth type of relationship is multiple correlation. And the another type of correlation is called canonical correlation. And there are some other versions of correlation which actually I don't know, but I have heard about it. That is called distance correlation. So there is a variety of a very long family of relationship. So we will cover these four types in the workshop. And canonical and distance correlation we normally cover in the advanced statistics and all. So let's start from the number one. The association is the correlation between nominal variables. So it is the relationship between, I explain, relationship between nominal variables and this is the relationship between ordinal variables. And Pearson correlation is the relationship between scale variables. Multiple correlation is the relationship between actual y and the predicted y, right? The actual y between the predicted y. Canonical correlation is between the observed and latent variable. Observed and latent variables. And this is also distance correlation between, this is also a correlation. So we are not, I'm not having very high much clarity about this. So we will cover the relationship between nominal variables, ordinal variables, scale variables, and this actual value of the variable and the predicted value of the variable. This predicted value of the variable comes from the regression model. So this we will cover in the regression analysis. So now today we are going to analyze the first part, and tomorrow I will analyze the second and third and fourth, and canonical and distance in some other workshop. So association is actually the lowest category or lowest level of relationship between the nominal variables. If you are interested in finding out the relationship between different nominal variables, then association can be applied. So you know that chi-square test. So this is measured by chi-square test, and the rank correlation is measured by rank correlation. There are two types of rank correlation. One is Kendall-Tau and second is Spearman correlation that we will discuss tomorrow. Pearson correlation is the relationship between the scale variables. Okay, now I'm giving you some examples. So suppose I want to know that is there any is there any relationship between the gender and shopping level? Do you think there is any relationship between the gender and the shopping level, right? Okay, so I'm just writing some of the examples here. Vinodji is asking what is the latent variable. Latent variable is that variable which we cannot measure directly, but we can measure them with the help of some statements. Like quality cannot be measured directly, quality can be measured with the help of some statements like responsiveness and empathy and all. So that is called latent variable, or it is a factor, or it is a construct. So these are the different examples of latent variables. So now I'm giving you some examples to think that what type of relationship we can apply between them. Number one, the first example I'm taking, is there any relationship between the gender and the shopping and the level of shopping? And the second example I'm taking, is there any relationship between the income group and the typophone. Is there any relationship between the age group and the type of or happiness level? Let's say happiness level. 4, is there any relationship between the medicine type and the improvement level? So there are different kinds of the relationship, and one more relationship I want to study. Is there any relationship between the designation and performance level? So if you see all these type of variables, in all these type of examples, we are interested in finding out the relationship between different nominal variables. Like gender is a nominal variable, male and female. Level of shopping, high, low. Income group, type of phone. Age group, it's also nominal. Happiness level is also a nominal variable. Let high level of happiness, moderate level of happiness, and low level of happiness. Medicine type. Sometimes in experimental design, we provide medicine to one group and placebo to another group. And we want to check, is there any relationship between the type of medicine and their improvement and the improvement of the patient. Sometimes we want to know that is there any relationship between the designation and the performance level? Can we say the like in universities, can we say the assistant professors are giving more publication as compared to professor, or professors are giving more publications as compared to associate professor or assistant professor? So we are interested in finding out the relationship between the nominal variables. So whenever we are interested in finding out relationship between nominal variables only, we have to apply chi-square test. So in all these cases, we are going to apply what? Chi-square. So this is called chi-square test, right? So this is the introduction of the chi-square test, where we can apply. And let me move to another part. The null hypothesis of chi-square test. So whenever you want to apply chi-square test, the language, what kind of language you have to mention in null hypothesis is that there exists no significant association between category 1, that is called x1, and x2. So here x1 and x2 are the two nominal variables, and we assume that there exists no significant association between x1 and x2. And what we have to check, how can we analyze this hypothesis? So you will apply two tests here. One is Call-Pearson chi-square test. So this is the one test you apply. Then you have to apply Cramer's V. So these two tests are very important. And then the third case, you have to find out the comparison of actual and expected values. So these three steps are very important in chi-square. So whenever you assume the hypothesis related to the chi-square, this is the language you have to use, and you have to apply 3 steps. Step number 1, see the Call-Pearson chi-square test value, see its probability value, p value, find out the Cramer V, and find out the comparison of actual and expected values. So step by step I will explain this. Now I am going to the explaining different basic concepts of chi-square test. So let me start the explaining you the logic. So what is the logic of chi-square test? Logic of chi-square test. So this is, if you understand this, then chi-square will be very intrinsic test to understand. So number 1, I'm giving you one example. So you are tossing a coin 10 times. So now what is the expected number of heads. What is the expected number of heads? So you say that the probability of head is 50%. So we can say the expected number of head is 5. So I hope you are agree with me that in this case we can have we can expect 5 number of heads. Now suppose actual number of heads is equal to 8, right? So when you take the difference expected, when you take the difference between expected minus actual, right, this difference is expected to be 0, but here you can see that this is not equal to 0. So now if the expected minus actual is not equal to 0, it means some association could be there. So in chi-square test, you just decide that what is the logic of applying the chi-square test. Let me explain you in a generalized way. So in every case, we are comparing the actual minus expected. So we always compare actual and expected, and there are two possibilities. The difference between them should be 0, and is actually 0. And suppose sometimes the actual minus expected is not equal to 0. So how we conclude that? If there is no difference between actual and expected, the answer is there is no association. There is no association. And if the difference is not equal to 0, it means association exists. Association exists. Okay, so we are applying the chi-square on this logic. So we compare actual and expected, and if the difference is 0, it means there is no association. And if the actual minus expected is not equal to 0, it means there is some association. There is some association. So I'm going to explain this with another example. So I hope you can give me the answer of that. So suppose in a city, there are 50 hospitals, right? And in the 50 hospitals, on any day, 100 births happens, right? There are 100 births. So now I am asking you, out of these 100 births, how many boys should be there? So number of boys, how many number of boys? So you can say that in case if the 100 births are there, the number of boys should be 50. The number of boys should be 50, right? But this figure is expected figure. This figure is expected, right? Now suppose the actual number of boys is 60. This is the actual, right? Now you can say this because the actual is more than expected. Because the actual is more than expected, it means there is some problem is going on with the hospitals, right? It means there is some problem going on in the hospitals. So in this way, we can conclude that there is some association between the number of births and the hospitals, right? So the comparison of actual and the expected is giving you the clue whether there is a association or there is no association, right? Okay, so this kind of association, how we can calculate it? So I'm giving you one example. I will solve this example manually, and then we will move to the software part. So now listen to this example carefully. Suppose in a college, I have this data set. The data set is like this. Okay, so this is the male employees and this is the female employees, right? So my X variable is employees. So we are having male employees and female employees. And my next variable is promoted or promotion in last 5 years. So this is promoted and this is not promoted. So I found that there are 20 male faculties in the department and there are 30 faculties in the department. These are 20 males and 30 females. So in total, there are 50 faculties in the department, right? So I hope you understand this. In the department, 20 males are working and 30 females are working. So I asked them whether you got promoted in the last 5 years or not. So for example, this is a hypothetical example. So 5 say that we got promotion in the last 5 years, and 15 say that we did not get promotion in the last 5 years. 15 females said they got the promotion, and 15 say that they did not get the promotion in the last 5 years, right? And the total of employees who got promoted are 20, and the total employees who are not promoted in the last 5 years is 30. So this is called observed data. Observed data. Now from this observed data, I want to calculate the expected data. So now I am telling you how to calculate the expected data. Right. The formula is expected. The formula is row total multiplied by column total and multiplied by grand total. So I will use this formula to find out the expected value. Now here actual value is 5. What is the expected value of it? So I will calculate 20 multiplied by 20 divided by 50. So how I did this? 20. This is 20 divided by 50. So this is the expected value of 5. Now how to calculate expected value of 15? So row total is 20, column total is 30. So I can write 30 multiplied by 20, and the grand total is 50. So now what is the expected value here? 15, column total 20, row total 30. So 20 multiplied by 30 upon 50. Similarly, this 15, 30, 30, 50. So 30 multiplied by 30 and multiplied by 50. So these are the expected value. So if I calculate it, the answer I will get is 8. And here the answer is 12. Here the answer is 12. And here the answer is 18. So now I have this answer. So now what I'm going to do, I will compare these values. So let me compare. Here the observed is 5, expected is 8. In this case, observed is 15, expected is 12. And this is 15 and it is 12. Right. So tell me if my calculations is wrong. And this is 15 and this is 18. So let me check it. 600 divided by 50, 120. Okay. Now these are the male employees, female employees, and this is promoted and not promoted. Right. So we will compare this column. Right. Now compare this column, and if after comparison you will get your answer. So it is expected that 8 male should be promoted, but actually only 5 males are promoted. And this indicate that 12 females were expected to be promoted, but 15 were actually promoted. So here we can say that the chances of promotion of females is higher than the male, right? So if you calculate this ratio, 15 upon 12 and 5 upon 8, so you can see the ratio. The ratio of female promotion is found to be higher than the ratio of male to be promoted. So the answer is that the chances of promotion of females is higher than the chances of promotion of the males. Now the question is that can we conclude only after comparing this, or is there some method of comparison? Yes, there is a method of comparison. What is the method? Now I'm telling you the exact method of calculating the chi-square value. I hope this calculation is clear to you. And let me apply the chi-square value. So how chi-square we can calculate? Let me explain you that. So how to do the calculation part? First of all, we made this table. This table is known as contingency table. Contingency table. And in this contingency table, we calculate the value of chi-square, which is equal to O minus E square sum upon E, right? So I'm showing you the calculation. This is 5 minus 8 square, and the expected value is 8, plus 15 minus 12 square divided by 12, plus 15 minus 12 square divided by 12, plus 15 minus 18 square divided by 18. So the software will take the total of all these values, and some value will come here, right? After that, there is a chi-square distribution. So what software will do? Software will check the value of this chi-square distribution and give you the p-value. So some basic concept I'm going to tell you here. Then after calculating the chi-square value, which is calculated with the help of this formula, and we calculate the degree of freedom, then the degree of freedom of chi-square is number of rows minus 1 and number of columns minus 1, right? So this is the degree of freedom. This is the row minus 1 and column minus 1, and we find out the probability value. Then probability value, if probability value is less than 0.05, it means null hypothesis rejected. So this is the logic of chi-square test. And after calculating all these things, then we calculate one more concept, and which will tell us this concept is known as, okay, now suppose the probability value tell you that there is a significant association between the two variables. Now I want to know what is the strength of that association, how that association is stronger, right? How much the strength is stronger, what is the strength of the association? So now I want to know what is the strength of association. So the strength of the association, so whenever you apply chi-square, you have to apply the strength of the association test. So this is called effect size. This is called effect size of association. So in the literature, this concept is known as effect size of association. It is measured by Kramer V and phi value. Phi is not applicable nowadays. Most of the researchers apply Kramer V, and which is equal to the chi-square value upon sample size multiplied by V minus 1, right? So this is the formula for Kramer value, and this n is the sample size. So whatever be your sample size, this is the sample size, and V minus 1 is maybe the R minus 1 or the C minus 1, whichever is lower. This is row minus 1, this is column minus 1. So whatever is lower, we will replace it with V minus 1, right? So suppose your row minus 1 is 2, column minus 1 is 3. So you will put 2 in place of V minus 1. So this is the value of Kramer V. And if Kramer V is more than 0.5, we can say association is a strong association. And if Kramer V is less than 0.5, then we can say the association is a moderate association. So Kramer V is one of the important method in analyzing the chi-square test. Okay, so let me write. So we have to find out Kramer V, which is equal to under root of chi-square upon n into m. So what is m here? So where I can write, in some books the formula is written like this: m is the lowest of row minus 1 or column minus 1. So if the Kramer V is more than 0.5, so we can say a strong association. And if V is less than 0.5, then it is called moderate association. So this point you should know very well in chi-square. And there is some confusion that should we apply phi test or not. So I say not required. You can completely ignore the phi test because Kramer V is replaced phi test already, right? One more thing which I want to explain here. I hope there is no problem in this Kramer V formula, because Kramer V is very important formula in case of chi-square test. You just read this concept again, because we are going to apply Kramer V in all the examples of chi-square test. So we compare chi-square test with 0.5, more than 0.5 strong, less than 0.5 moderate. Okay. Now one thing I also want to tell you, that in table, the table which we make in chi-square test, right? So this is the table, and suppose we are having this kind of table. Suppose this is assistant professor, associate professor, and this is professor, right? And this is the poor performance or moderate performance, good performance, exceptional performance, right? So because nowadays most of the companies are dividing their employees in 4 categories: poor performance, moderate performance, good performance, and exceptional performance. In case of poor performance, they decrease the salary. In moderate, they keep the salary same. In good performance, they provide 1 increment, and in case of exceptional performance, they provide more increment. Okay. Now, in this case, how many rows are there and how many columns are there? So you can tell me very easily. In this table is known as contingency table. In this table, number of rows are 3 and number of columns are 4. So 1, 2, 3 and 1, 2, 3, 4. So the degree of freedom of this is 2 multiplied by 3, which is equal to 6. So how this 2 will come? 3 minus 1 multiplied by 4 minus 1. 2 multiplied by 3 is 6. Now in this table, the rule, there is a very important rule. There is a very important rule. Now what is the rule? The rule is that the rule of chi-square is that 80% of the cells of the table must have actual frequency more than 5, right? So in this case, how many cells are there? 1 2 3 4 5 6 7 8 9 10 11 12. So 80% of 12 in this cell, the 80% of 12, 80% of sorry, this is 12. It approximately, it is equal to 9, approximately 9, right? 80% is approximately 9. So it means at least in any 9 cells, the actual frequency should be more than 5. So this assumption should be fulfilled. Otherwise, we cannot apply the chi-square test. So whenever you are going to apply the chi-square test, kindly check that whether 80% of the cells must have the actual frequency more than 5. So this is one of the rule which is very important to be fulfilled. And after that, now I'm moving to the demonstration.